I know some of you only had a couple minutes to try these, but let's take a look and see how we come out here. The top one, we want to come up with a common denominator, and we're going to multiply the whole thing. So we have 4, 6, 8, and 3. What's our common denominator going to be? 24. Very good. Now remember, if you're stumped on that, you can do factoring. 4 factors into 2 times 2, and 6 factors into 2 times 3, and 8 factors into 2 times 2 times 2. 3, well, that's just 3. If you look at it, there's nothing that they all have. This one has 2 2s, so we got to make sure they all have 2 2s. This is 1, so we need another 2 here. That one's definitely got 2 2s. We need 2 more 2s here. This one has a 3, so we need to make sure they all have a 3. Well, that one needs a 3. This one needs a 3. The 8 actually has 3 2s, so we need to go back and add a third 2 to all the others. Now they all have 3 2s and a 3. So 2 times 2 times 2 is 8, times 3 is 24. So that's how we get the 24. So 24 is the common denominator for 4, 6, 8, and 3. So now we're going to multiply the whole equation by 24. So we've got 24. We're going to multiply the 2x minus 7 over 4. So 24 over 1 times 2x minus 7 over 4. Well, the 24 and the 4 cross cancel, give me 1 and 6. So now I've got 6 times 2x minus 7. 6 times 2x is 12x. 6 times negative 7 is negative 42. So now 24 times the next one. Now there's a negative here, so I've got to be careful with that. I'm going to put the negative with my 24, and you'll see why in just a second. We got to think of this as having parentheses here. When we put it up here, we're actually going to write it with the parentheses there. So that negative would be it'd be like multiplying that whole thing by a negative 1. So putting that negative with the 24, it is going to be multiplying that whole thing by a negative. So now we can cross cancel with the 24 and the 6, give me 1 and negative 4. So negative 4 times 5 is a negative 20x. Negative 4 times negative 2 is a positive 8. Equals, on the other side, 24 times the 3x plus 1 over 8. So 24 over 1 times 3x plus 1 over 8. Again, 8 and 24 cross cancel, giving me 1 and 3. 3 times 3x is 9x, and 3 times 1 is a positive 3. Next, we got the 24 times the x minus 7 over 3. Positive, so we don't have to worry about anything there. 24 over 1 times x minus 7 over 3. 24 and 3 cross cancel, giving me 1 and 8. 8 times x is 8x. 8 times negative 7 is a negative 56. Now we're going to combine what we can. On the left side, 12x and negative 20x is negative 8x. Negative 42 and 8 is a negative 34. On the right side, 9x and 8x, 17x. 3 and negative 56 is a negative 53. Questions so far? Okay, now we got to get rid of one of the x's. We have an x on each side. I'm going to get rid of the negative 8x. I'm going to add 8x to both sides. So we have right now is negative 34 equals 17 plus 8x is 25x minus 53. So I'm going to go back over here. I'm going to rewrite that. To solve this, I am going to add 53 to both sides. So this is now 19 equals 25x. And I'm going to divide by 25 on both sides. X is 19 over 25. 19 divided by 25 can't be reduced, so it's 19 25. Anybody get 19 over 25? On your calculator? Okay. Anybody have serious questions on what I did there? After we do the next one, do you want me to give you another example like that to do? Maybe a touch simpler? Okay. This next one looks a little bit more polite, but isn't really too much more kind than that last one. Start out with each set of parentheses moving left to right here. We'll do everything on the left side of the equal sign, then we'll go to the other side. 5 times 3x, 15x, 5 times negative 7 is negative 35. Good. Next set of parentheses, there's nothing to do in the parentheses. What do we have to do to them? Times a negative 3. Make sure you keep that negative there. Negative 3 times 6x is negative 18x. And negative 3 times negative 5, positive 15. And we have our positive 3 there yet. Let's do some combining. 15x and negative 8x, or negative 18x is negative 3x. Negative 35, positive 15, and positive 3 adds up to negative 17. Negative 35 and positive 15 is a negative 20, plus 3 more is negative 17. On the right side, we have our parentheses. First one is times 2. 2 times 3x. 6x. 2 times 1 is 2. Next, we're multiplying by a negative 3 again. Negative 3 times 4x. Negative 12x. Negative 3 times negative 8. Positive 24. And then we got the plus 3x. So we will combine. What can we combine here? Perfect. 6x, negative 12x, and positive 3x. 6 and negative 12 make negative 6. Plus 3, negative 3x. 2 and 24 make 26. Now we have an x on each side. We need to get rid of one of them. Which one's smaller? They're both the same, aren't they? So if I add 3x to get rid of the negative 3x, that's gone. Adding 3x here, that one's gone. I now have negative 17 equals 26. Is that true? No. Is there any value I could ever put into this equation for x that would make that true? No. In no world does negative 17 equal 26. It's not, no way to make that true. So this equation up here has no solution. That wasn't very nice, I know. When the variables all cancel out and disappear like that, there are two possibilities. Like this one, there's no solution because these two numbers don't equal each other and there's no way to ever make them equal each other. The other possibility might look like this. Make sure I'm going to get this right now. So if we're looking at this, first thing we have to do is we have to combine the left side here. Actually, you know what? I'm going to give you guys a few minutes. See what you come up with that. You guys need another minute or two? Okay. Let's see what you got. So the first part we have to do is we have to combine this side over here. Now I'm going to do it like this. 2x squared minus 7x plus 8. We got the x squared and the positive 2x go like that. We are subtracting down each column. So 8 minus nothing is still just positive 8. What is negative 7x minus 2? Negative 9x. Negative 7 minus 2 more is negative 9. 2x squared minus x squared. Just 1x squared or just x squared. On the other side, we still have x squared minus 9x plus 8. So we've got the x squared on each side. I'm going to subtract one of them, and they both disappear, which is good, because that's something we had mentioned was, if there's x squareds in the equations, for right now, you've got to get them to disappear. They've got to go away or we're in trouble. 9x squared plus 8 equals, or sorry, negative 9x squared plus 8 equals negative 9. Let me try that again. Negative 9x plus 8 equals negative 9x plus 8. Now we've got an x on each side. We're trying to get rid of them, so we're going to add 9x to both sides. We're left with just 8 here. That 9x goes away as well, so we're left with 8 equals 8. Once again, the variable disappears. But what's different about this one compared to the last one we did where the variable disappeared? Well, the x squared did disappear. The x's disappeared up here. This had x squareds in it, and they disappeared too. But here we got 8 equals 8. Is that true? Yeah. Is there any value I could ever put in here for x that would ever make 8 not equal 8? No. 8 will always equal 8. This equation will always be true no matter what I put in there for x. So this is every real number, or every number. Because no matter what I put into that equation for x, it will always be true. 8 will always equal 8. Up here, however, because what I got was two numbers that were not equal, there's no way to ever make them equal. There's no solution to that equation. So that's two different possibilities when your variables disappear. Now I promised to give you another one with their fractions in it, maybe a little bit nicer one. I'll do it this way. If I'm going to be nice, I gotta try harder. Okay, I'm going to give you a couple minutes to try this one. Okay, for this one, we need to find a common denominator again. I've got 5, 10, and 2. For the numbers, what's the common denominator going to be? 10. Now, for the variables, you take the highest power of the variable. In this case, that's going to be just x. Yes. So now I've got to multiply that 10x by each piece of the equation. So I've got 10x over 1 times 4 over 5x. So I multiply that out. 10x times 4 is 40x. 1 times 5x is 5x. The x's divide out. 40 divided by 5 is 8. Got that negative again there, so I'm going to, just like I did before, I'm going to put it with the 10x. So negative 10x over 1 times 3 over 10. That multiplies out. It's going to give us negative 30x over 10. Negative 30x divided by 10 is negative 3x. So I've got 8 minus 3x on the left side. On the right side, we're going to do 10x times 7 over 2x. So 10x over 1 times 7 over 2x. 10x times 7 is 70x. 1 times 2x is 2x. X's divide out. 70 divided by 2 is 35. 10x times 4 fifths. So 10x over 1 times 4 over 5. 10x times 4 is 40x. 1 times 5 is 5. 40x divided by 5 is a positive 8x. Now we've got rid of all the fractions, we can just go ahead and solve. What would we do first? Add 3x to both sides. We've got to get rid of one of the x's. So we're left with 8 equals 35. 8x plus 3x is 11x. Then what? subtract 35. So 8 minus 35 is a negative 27 equals 11x. And then what? Divide by 11. Negative 27 over 11 is a negative 2 and 5/11. At least there's an answer to this one, right? Any questions? Okay. Well, tonight we are going to start looking at problems similar to this one, only we're going to take a different approach. So far, every time we've run into a problem like this where the answer didn't come out even, we've used this fraction approach. Tonight we're going to start looking at decimals. And of course, decimals, the key to decimals comes down to place value. So let's take a little bit of a review of our place values again. From our decimal point, or from the end of the number working backwards, I'm just going to write these out numerically. We have the ones, the tens, the hundreds, the 1,000s, the 10,000s, and the 100,000s, and then so on. Millions, 10 millions, and everything else after that. Well, if we look at these numbers, there's a pattern in the numerical, what's happening numerically here. Every time we move one spot to the right, the numerical value of that is divided by 10. From 10,000 to 1,000, we're dividing by 10. From 1,000 to 100, we're dividing by 10. 10 to 1, we're dividing by 10. So if we keep going with our place values here, that pattern has to continue. 1 divided by 10 is going to give us 1/10. 1/10 divided by 10 is 1/100th. 1/1000th. 1/10,000th, and so on. Now I get asked a lot, why isn't there a ones place? Why does it go 10, 100,000, tens, hundredths, thousandths, but over here it's 1, tens, hundreds? Well, it's because of this right here that I just showed you. We have to divide by 10 at each spot. And there's no way that you can get a ones on the other side of the decimal point. So anyway, looking at these place values, you might be thinking that they look a lot like fractions. And that's because that is exactly what they are, is fractions. Decimals are often called decimal fractions. They are nothing more than a fraction that is being expressed in a common denominator or standard denominator that is a power of 10. So if I have 0.38, that is pronounced 38 hundredths, and it is hundredths. I mean, making that into a fraction, it's as simple as putting 38 over 100. So the way you would do this to turn a fraction or turn a decimal back into a fraction, it is simply a matter of, one, you could write it how you'd pronounce it, 38 hundredths. Or you write out the number 38, and the denominator is the place value of the last digit of the decimal. So if I have 0.0375, as a fraction, that's just 375 over, what's the place value of that last digit? Tenths, hundredths, thousandths, 10,000ths. I'll show you a little trick, by the way, double check yourself. There's 1, 2, 3, 4 decimal places there. There's going to be 1, 2, 3, 4 zeros in my denominator. Now, looking at those, both of those can be reduced. Both of them can be divided by what? Anybody? What's that? 5. Okay, they can be divided by 5. Very good. That would make this, oh, what the heck is that? 75 over 2,000? Something like that. Now they can still both be divided by I would go 5 again. 15 over 400. Are we done? Say no. Still divide by 5. Not 15. You could have divided by 25 or 125 to begin with. It would be 5 times 5 times 5. Yeah, if you divided by 25 to begin with, you would have got 15 over 400. If you divided by 125 to begin with, it would have taken you to 3 over 80. What if we have a whole number on it, like 4.632? Well, the 4 in front of the decimal point, this is actually what they call a mixed decimal is its technical name. It's just like a mixed fraction. We have a whole number portion, and then we have the fractional portion. So the 4 in front is just the whole number part. 632 then over, tens, hundreds, thousands. 1, 2, 3 decimal places, 1, 2, 3 zeros. Now, of course, I can reduce that fraction. 632 and 1,000 can both divide by, well, they're both even, so I'd see that right away. They divide by 2. So it'd be 316 over 500. Are we done? Putting dividing there, so obviously no. What can they still be divided by? 2 again, they're still both even. So 316 divided by 2 is 158. 500 divided by 2 is 250. Are we done? No, they can still both be divided by 2. They're both even. 158 divided by 2 is 79. 250 divided by 2? 125. Are we done? No, why not? Careful, that's 125. That's odd. The only thing 125 can be divided by is 5. 79 is actually prime. So it can't be reduced. Are we done? Oh, sure. You are right, though. We're not done. You have to put the 4 up there. Yes. You have to hold it right. Good catch. That is the single most common mistake I'll see on these. If there's a whole number, people forget to put that back with it. So I'm going to have you guys try one of your notes. Let's do 2.084. See what you come up with. So, we've got the 2 out front. What's our fraction? To start out with, before we reduce. 84 over 1,000. Good. 3 decimal places. Tens, hundreds, thousands. Then what can we do? Both can be divided by 4, giving me 21 over 250. And that is it. So then what else do I...
Oh, you can divide by 4 again.
Careful. That should be 21.
You can do that. How many ways to divide by 4?
5.25. Okay. That's okay. So you got the 2 up front. Now on your calculator, by the way, you know you can put in 84 ABC 1000, and it should reduce it for you. 1000. Do the 84 first.
84?
Yep, then ABC 1000. 21 over 250?
Yeah.
Okay. Any questions? Okay. Now, I'm not going to spend much time on comparing decimals because it's just like comparing other numbers. But we are going to take some time to deal with some rounding with decimals, only because there's an application that's very important. If you're going into mechanical design, architectural design, or anywhere where you're dealing with measurements, you have to be able to take a calculated measurement and turn it into something that's standard. Whether it's a tool size, a standard dimension that would be used for construction, or anything like that. If you let's say you calculate something and you calculate that the dimension has to be 0.418 inches. Well, if you're dealing in construction, there's nothing in construction that's 0.418 inches. In construction, everything is dealt with as quarters or eighths or sixteenths or whatever. And in some manufacturing and other applications, it's done that way as well. So let's say we need this to the nearest 16th of an inch. The way we would do that is we would take 0.418 and we put it over 1. It's now a fraction. Now notice the decimal point's still there. I didn't change it to thousandths or anything like that. It's just 0.418 over 1. Simplest way I could possibly turn it into a fraction. Right now, that fraction has a denominator of 1. I want it to have a denominator of 16. How do I make it have a denominator of 16? Multiply by 16. I can multiply both the top and bottom of a fraction by the same number. 1 times 16 is 16. 0.418 times 16 is 6.688. So to the nearest 16th, that's 6.688 sixteenths. Now obviously that's not to the nearest 16th. That's a decimal right now. But what this is telling us is that this is between 6 sixteenths and 7 sixteenths. Well, which one is it closer to? Well, 6.6, that would round down to 6 or up to 7? Up to 7. Yeah. Because this is, if this digit, the 10th digit is 5 or larger, it rounds up to the next whole number. We might have 0.713 inches. We want it to the nearest 32nd of an inch. So we're going to do the same thing. 0.713 over 1. This time, what do we want the denominator to be? 32. So what are we going to do to this? Times 32 on top and bottom. 1 times 32 is 32. 0.713 times 32 is 22.816. Now again, this is telling us that we are between 22 30-seconds and 23 30-seconds. Which one are we closer to? Yeah, 2.8, which means it's closer to the next one up, 23 30-seconds. Any questions? How would this change if I did this? 5.199 inches, and I want it to the nearest 1/8 inch. Well, I'm going to a different fraction here. I'm not going to 16ths or 30-seconds. I'm going to eighths. But that's not what I was getting at. I have a number in front of the decimal point here. That 5 changes absolutely nothing. It's 5 whole inches. That doesn't convert to a fraction. It's going to be 5 whole inches whether it's in decimal form or fraction form. So all I'm going to work with here is the 0.199. Again, I'm going to put it over 1. I want it to have a denominator of 8, so I'm going to multiply by 8 over 8. 1 times 8 is 8. 0.199 times 8 is 1.592. Now again, that is between 1/8 and 2/8. Which one is it closer to? 2/8. Yeah, that's 0.5. That would round up to 2. So 2/8. Even though I'm asking for it to the nearest 1/8, I can still reduce that to 1/4. Because if, let's say, you're looking for a tool size or a standard size of a, I don't know what it is you'd be sizing there, but it's not going to be listed as 5 2/8. It's going to be listed as 5 1/4. Well, what if I wanted to change, now instead of changing decimals into fractions, we've seen two ways. We've changed decimals into exact fractions. That was what we did up here, where we took it to its, whatever its name was, its decimal place. Now we changed decimals to approximate fractions, to the nearest given fraction. What if we wanted to go the other way? What if we have a fraction that we want to turn to a decimal? Well, we'll start out with one that all of you know. 3/4 becomes what as a decimal? 0.75. If we didn't know that, how would we find it? Well, we've said this a couple of times, that a fraction and a division problem are kind of interchangeable. So 3/4 can be thought of as 3 divided by 4. If you divide that on your calculator, it will give you 0.75. Before the night's out, we'll look at how we do that by hand without using the calculator. For right now, we only know how to use the calculator. So if I had 5/7, how am I going to turn that into a decimal? 5 divided by 7, bless you, which will give you 0.714285571 approximately, right? You can check me if you want to. Yeah. Remember, I've said before, math, the calculations in math are all about patterns. And once you start to see the patterns, the calculations are easy. The tough parts of math is, one, figuring out what process to do, and two, seeing the patterns. Once you see the patterns, it's all there. It is time to take a break, so let's go ahead and take a break. It is 4:20. Let's come back at 4:30.